Okay, good morning, guys. All right, so today we are going to carry on with the types of rainfall, talking about rainfall amounts. Um, and yeah, basically today's lesson, I don't think will be too long because type of rainfalls is not too difficult to, okay, wait, not say not too difficult to understand, but maybe it's faster to process the thing, okay? So after the two types of rainfall are done, and depending on the time that I have, I may touch a bit on pressure, but if not, then I'll just leave pressure to the next lesson completely. Okay, so I'll just stop at rainfall for this lesson, so you can have a shorter, in a sense, shorter lesson for this particular portion. Okay, we are in a way ahead of time, so that's good news. Like I said, all right, if you do have any questions, please post them. If you think you really need to ask me live, you can also let me know. So yeah, that's always a possible avenue to explore. Okay, now there is one section of your notes before I start on the types of rainfall. Right before the types, okay, they show you one section which talks about amount of rainfall. Okay, how do you classify amounts of rainfall? Okay, let me show you that portion first. Okay, so I'm referring to this. Sorry. Uh, Yeah. Okay, so I'm referring to this portion. All right, they say high rainfall above 1,500 mm, low rainfall below 250 mm. Okay, so I hope you can freeze the thing and copy it down. All right, why is this necessary, and what are we referring to when 250 and 1,500 mm is involved? Now, do remember when we talked about temperature, we listed down a few so-called important ways of calculating temperature. Okay, one of it was mean annual temperature, then was total annual not total, annual temperature range, and finally diurnal temperature range. So these three were the most important ones. We don't find total temperature because that's pointless. Okay, however, when it comes to rainfall, what do we usually look at is total annual rainfall. Okay, RF rainfall for short. All right, so we look at total annual rainfall. We don't usually look at monthly rainfall rates or etc. But the other figure, I mean, the other thing other than total annual rainfall is we look at distribution of rainfall. Okay, you will understand distribution of rainfall when I reach the last part of weather and climate, which is the types of different types of climate. Okay, that's when you understand better what I mean by distribution of rainfall. So that's not of a majority I mean, that's not of a main concern right now. But we do want to look at total rainfall. Below 250 mm across a year, that is considered as low. Okay, above 1,500 mm in a year is considered as high. Now, definitely Singapore is in the high range. We are definitely not in the low range. Some countries surrounding us, the Southeast Asian nations, most of these Southeast Asian nations are also in the high range. Okay, about usually we end up about 2,000 plus and above. Okay, even higher than 2,500. On a really rainy year, it can be even 3,000 plus. All right, so that's definitely there. Now, if you go to the higher latitudes, especially inland areas, that's where you tend to find rainfall which is very low, about 250 mm or even lower at certain places. Okay, so just take note of this, these calculations, because when you describe climograph in the future, that's also at the last part, the types of climate portion. You do want to use terms like high rainfall, low rainfall, and things like that. Okay, so you want to use these terms to classify the climograph, same as what we would do for temperature. Okay, like, is it high mean annual temperature, high annual temperature range, or high diurnal temperature range? Okay, so we do use these terms. So take note of this. This will be low. Okay, anything in between is definitely considered moderate. So you don't need to worry too much about that. Just remember that anything in between, you just label it as moderate. Okay, same as the temperature logic. Okay, yeah. Now, today when we talk about types of rainfall, basically there are two main types. One is convectional, and the other one is relief. Okay, later I'll let you copy the notes. But just a few pointers before we carry on. All right, these are the two types of rainfall that we usually experience in the world. Okay, there is one more type actually that I believe is more common than relief. It's called frontal rain, but it has been removed from the JOG syllabus for a long time. Okay, when I was a student, we used to learn that. I don't know why, but yeah, but it doesn't matter. So that has been removed. Frontal rain, for your own knowledge, it happens more so in the higher latitude areas, like UK. UK is a place whereby frontal rain is pretty common. If you have traveled to UK, you realize that rainfall there is quite annoying, and it does carry on for quite some time. All right, it's usually very rainy, misty, foggy. Okay, yeah. So you will learn relief and convectional. Now the one that is more common is convectional in Singapore. Okay, in Singapore, the one that is more common is convectional. We don't experience much of a relief rain. You will understand the reason why later on. Okay, and the key pointer that I want to take note is that two of these rainfalls have a different reason or a different starting point to their origin. Okay, and you must know this starting point so that you understand what's going to happen later on. So for convectional, it's pretty simple. We are talking about heat, okay, high heat, and that's why Singapore is so exposed to it. Okay, because temperatures are here are very high. We are near the equator. Back again, revise. All right, latitude at equator. The sun solar angle will be at 90 degrees. Temperature will be very high. Okay, here we are talking about relief. All right, relief, which is usually refer. Okay, relief means the terrain. Okay, relief means the terrain. When we, oh my god, I don't know why I write this two times. Sorry. uh, Relief rainfall, we are talking about terrain. Okay, terrain, which refers to how land is being structured, etc. Now in this particular relief rain, what we are talking about is actually mountains. Okay, mountains, how do mountains cause rainfall? And that is why we don't really experience it in Singapore. We don't really have a mountain, we only have a hill, and the hill is not going to cause any much of a difference. Okay, all right, so let's move on to convectional rainfall. Okay, so when we erase this, okay, let y'all copy the notes first. Okay, so I'm going to scroll down. All right. Um, okay, please copy down whatever. Oh, sorry, this is not the one. Please copy down whatever that's necessary first. Okay, before we carry on with the lesson. Okay, let's start sharing now. If you haven't copied yet, just freeze the image and carry on. Okay, so I would usually what I'll do when it comes to weather and climate, I'll just draw the diagram out. Okay, towards the end of the lesson, I will tell you what is the difference between a labeled diagram and annotated diagram. You need to know the difference. Learning how to draw this relief rain and convectional rainfall diagram is a good skill. Although recently in these years it has not been tested. So don't focus too much on trying to memorize the drawing, but do know roughly what is going on in the drawing. Okay? Okay, so there is a drawing there actually inside your notes. I suppose that there is a drawing there. But yeah, of course, I'll add on to this thing. Okay, now there are a few things that I wanted to take note of. let's see, this is land. Okay, so we revise back again. All right, incoming shortwave radiation will hit the Earth. So this is shortwave radiation. Now this shortwave radiation is going to be absorbed by the Earth's surface. Okay, Earth's surface will absorb it. All right, and then it will give back your long wave radiation across the surface. And this long wave radiation, sorry, just a moment. I'm not going to go through exactly all the specific words that I put down there, because you can refer to them while I'm explaining. So my reason why I'm drawing this is more to explain. I don't have a big whiteboard, so I can only do it in a very small manner. Okay, so this will be a long wave radiation. Now what this long wave radiation does is that it heats up an air parcel. So once again, we are using this concept called the air parcel. Okay, so I did talk about this concept yesterday when we were not yesterday, Friday, when we were talking about all the rainfall formation, etc. Okay, so we are dealing with this thing called the air parcel. Now this air parcel, you don't see it in real life. All right, it's a conceptual understanding. Depending on where the location is, the whole bunch of air that's around there, the molecules and everything, they get heated up. Okay, you consider them as air parcel. You don't see them, but you know that it exists. Okay, so this air parcel gets heated up. What happens inside the air parcel is that if you learn in physics or is it chemistry, either one of it, your particles will start to move a lot faster because they gain energy. All right, particles start to move a lot faster. This air parcel will expand. Okay, heated up will expand. As as it expands, it will rise. um, Also, because the particles are moving so fast, all right, it becomes unstable. Okay, so you have an air parcel that's heated up, it's large, okay, it's expanding, it's rising up, and it's pretty much unstable. It's not going to, yeah, it's unstable. Okay, now throughout this entire process, we have evapotranspiration going on. Okay, so everywhere around this area, there will be some form of evapotranspiration. Okay, evaporation from drains, other forms of water catchment areas. Okay, as long as it's water on the surface or even from other equipment, etc., this water is going up to this air parcel. Okay, as water vapor. All right. Now, do remember this. Okay, it doesn't necessarily only has to originate from the sea or from a large water source. Water can be obtained from land itself. Okay, so it means water vapor can be obtained from land itself. It heats up from all other locations, and it goes up to the air parcel. Okay, not just the sea. So you don't, when you draw this diagram, if you are being asked to draw, don't just draw the one with the sea. Okay, draw it with the land instead, because you need the land to understand the concept of short-wave radiation, long-wave radiation heating up the air parcel above the land. Okay, so this air parcel is going to rise. Now, in your diagram, we always want to draw this dotted line. What is this dotted line? It's your dew point temperature. Okay, so once this air parcel starts to cross the dew point temperature, now by now you should know what will happen next. Okay, because I did mention about this. When it crosses dew point temperature, you will have condensation. Okay, saturation first and then condensation. Okay, when it condense into the condensation nuclei, okay, the particles, the dust particles, etc., you get a large cloud that's going to be formed when all these particles are coalescing together. Okay, then you get a large cloud that's formed. Okay, condensation, which leads to cloud formation. All right, now of course, now I can't show it in this whiteboard because it's too small. Do remember convectional rainfall, not say do remember, sorry, convectional rainfall results in cumulonimbus clouds. So this whole process is a very unstable process. it causes this whole air to rise up really fast. Sorry, give me a minute. Okay, it causes this whole air to rise up very fast, going up all the way. And at the top of the whole thing, you have these cumulonimbus clouds, which are forming. They're large, okay, in terms of width, but more importantly, they are large in terms of height. So I can't show you in this whiteboard. Okay, just imagine it's going to grow a lot higher to higher atmosphere levels. Okay, so if you see a very dark, towering cloud that's about gray color, grayish. Okay, that is your cumulonimbus clouds. Okay, those the ones that you see in Singapore most of the time is the one that is going to indicate that there's rainfall. It is the cumulonimbus clouds. Okay, it's thick, it's filled with a lot of water molecules, a lot of water inside. That's why you can't see through the clouds. Unlike some other clouds which are thinner, okay, whereby there's not much of a water molecule present. Okay. Now, at this point, usually what happens is that the water droplets okay, water droplets will become too heavy, and once the water droplets become too heavy, you have convectional rain that falls on the surface. Okay. Now, just take note, convectional rain, as indicated in your PPT slides. Okay, it's short, it's intense, and there is usually a thunderstorm. Okay, more particles, longer cloud. Okay, I mean a taller cloud. All right, larger separation of the particles. Okay, we're talking about the positive and the negative particles. All right, so you're going to have a situation whereby the connection between the bottom and the surface is going to be a lot stronger, causing this lightning to occur, or a thunderstorm to occur. Okay, so definitely short, intense. It's a thunderstorm. Now, what 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 does this mean? What does this rain imply? Okay, so a few things to take note. Okay, so I'm going to erase this. Just anything that you want to copy down, copy down. If not, then most of it is actually inside the notes. But I'm going to erase this, and I'm going to tell you the implications of a convectional rainfall. Okay. Okay, so what are the implications of this convectional rainfall? Now, this is something that is not inside your notes or not inside your textbook either, okay? But I believe it's quite important for you to understand this so that you know how it kind of links to the other issues in Gateway 2 that we will cover in next term or end of this term, okay? Now, what are the implications of this thing, of convectional rainfall? Now, the first thing first is going back to what I said, all right, short, is intense, and they are usually accompanied with a thunderstorm. Okay, now this is very common in Singapore. Number one, before we even go to implement implications, we want to understand when it happens in Singapore. Okay, so I don't know if you recall, but I did mention this at the very start of the very first lesson on weather climate. I mentioned something about why sometimes, okay, you might feel that every time you're going to train or you're going to do a CCA, outdoor CCA, or you want to play football, you realize in the afternoon it starts to get dark and it starts to rain. Okay, what is the reason? That reason is mainly because of convectional current. Now, usually temperature on the Earth's surface is warmest at about 1 p.m. Okay, right after the time period whereby the sun is highest up in the sky. Okay, which is about 12 plus p.m. Okay, so after the heat is being absorbed at 1 plus p.m., it is the warmest. Your long wave radiation is coming out the most. Okay, so it's going to start the process. So just now the whole process that we understood is going to start the process at about 1 p.m. plus, and slowly you get the unstable air parcel that's going to rise, go up to the atmosphere, and it's going to start up the whole cumulonimbus clouds, etc. And rain will start at about maybe 3 p.m. plus, 4 p.m. plus, last all the way until about 5 p.m. plus. Okay, so that is why it happens. I mean, that is why you observe that in the afternoon or in the late afternoon, you tend to find that there is rainfall, okay, in Singapore. But also sometimes it doesn't exist because there must be enough water vapor. So if it's a dry season period, like currently where what this kind of season that we are in now, um, you don't have much water vapor coming up, so you don't have much of a rainfall happening. Okay, so you need water vapor to be in the air. So do remember, saturation is 100% relative humidity. You need the actual amount of water vapor in the air to increase to the highest amount before there can even be rainfall. So if you have high temperatures, very high temperatures, plus not enough water vapor, then definitely there's not going to be any convectional rainfall happening. Okay, now then, so what are the implications of this? Okay, so definitely floods are an implication. Okay, why? Because this rainfall is very short, very fast. At a very short amount of time, a high amount of water is being released onto the land. When the land can't take it anymore, you realize that the water can't be drained out, and because of that, you find water on the surface. Okay, so that's why you tend to have floods. In the past, Singapore did mention that, I mean, we tend to call it what, bonding. Okay, we did mention about bonding before, but nowadays I don't think they use that term anymore. They consider it as flood. Why is it that there was a period whereby floods were almost non-existent? Okay, now it's coming back again. Reason why is mainly climate change. I will talk about that when we go to gateway 2. Okay, so floods definitely is an issue that is caused by this rainfall. Uh, yeah, convectional rainfall. Okay, in more serious, sorry, um, in very rare occurrences like the one that I showed you, yes, for the previous lesson, do remember that cumulonimbus clouds is a pathway to hailstones. Okay, it might happen, very rare, but in Singapore, yeah, in Singapore it's very rare, but it might happen. Okay, so floods, hailstones, yeah, not much of an other implications. Also take note, this is the kind of rainfall that farmers actually do not prefer. Okay, farmers don't prefer this kind of rainfall. Reason why is because this kind of rainfall is usually too extreme. Seeds get washed away. The land that's being plowed gets destroyed. Okay, too flooded, too much water, too much saturation. So farmers do not like this rainfall as well. I'm saying this earlier right now because next year when you learn food topic, we will talk about this rainfall and the whole issue of farmers and etc. Okay. Yeah, so that's it for convectional rainfall. Right, we'll move on to relief rainfall. You want to copy this down because this is not in your notes. So if you want to copy it down, you can copy it down. Okay. Okay. All right. So now we go move on to relief rain. Relief rain. Yeah, like I said, we don't experience it in Singapore. Okay. Definitely not. There is an example that's given there in your notes. I think it's San. Sorry, not San. Andes mountain range. Later I'll show you. Okay. Okay, why don't you all copy the notes section first? Oops. Okay, you can copy down the notes first, all right? Okay, let's carry on. Okay, so back to the board, all right, relief rain. So you now have air that's coming in from the ocean, okay, sea, ocean, whatever large water mass that's outside of the mountainous region. Now, do note that this mountainous region must be close to the uh, water body, okay, but must be close to the coastal area. If it's in the center of a location, then it will not have any effect. It doesn't cause relief rain. It will just be a normal mountain that's down there. Okay, so same as Bukit Timah Hill. All right, Bukit Timah Hill. Maybe if it's at the coastal region, it could possibly cause relief rain, but it's not. It's in the center of Singapore, so it is not going to be much of an effect. Okay, so take note that it must be at the coastal region to cause this effect. So you get a warm parcel of air that's coming in from the ocean. So you got warm, moist air, okay, that's coming in from the ocean. Now, do recall that just now when the convectional rain air parcel went up, it's because of heat, okay? High heat that causes the particles to become faster, causes the air parcel to expand, it goes up. Now here, you don't really have that high heat element, okay? It's warm, but it's not super hot. Okay, so what happens is that the relief, okay, or the mountain, okay, the relief of the mountain is the portion that's going to force the air upwards. Okay, so instead of the other way around, whereby heat is going to force it, now is the relief. So this is what I mentioned, but at the start of the lesson, you need to take note at what is the cause of the origin. Okay, the origin here is the relief, the mountain itself. Okay, causing it to go up. And once again, we will have a dew point temperature dotted line here. Um, okay, what happens after this dew point temperature? It crosses and then there's saturation, there's condensation that's going to take place, and then going to be clouds from here. Okay. Now, here, we are not talking about cumulonimbus clouds. Okay, there might be cumulonimbus clouds, but most of the time it's not. It's just dark clouds. There are other names, but we don't need to know names for this particular relief rainfall. Okay, so you have cloud formation. Now, once again, when the water droplet is too heavy, I'm not going to write it here, there's not enough space. When the water droplet is too heavy, it will fall as rainfall. Okay, so here is where comes the so-called complicated part. Okay, actually it's not very complicated, but let's divide this mountain into two areas. Okay, here is the windward side. Sorry, windward side. Here is the leeward side. All right, you must know this when it comes to relief rainfall, especially if you're talking about explaining its formation and its effects. Okay, windward side, leeward side. Windward side is where the rainfall falls. Okay, so you got the clouds here. Um, the water droplets are going to get heavier. It's going to start dropping on this side. Okay, the clouds are on this side of the area. It's going to go up this way and it's going to rain here in this windward side portion. Okay, Now, once these clouds go to the other side, what happens to them usually is that first thing first, these clouds are going to go up to a high atmospheric level. Okay, they're going to go up to a high atmospheric level because definitely if you are pushed up a mountain, you're going to reach a high atmosphere level. Go back to altitude. If you do reach a high atmosphere level, first thing that is going to happen is a temperature drop. Okay, a dramatic temperature drop. All right, now once this temperature drops, you have the next effect. All right, sorry, not once this temperature. Okay, yeah, okay. Once this temperature drop, it will become then simply, all right, it will become cooler. Okay, instead of expanding, it will contract. All right. And the next thing, now do recall that water vapor that originated from here, it's already here. When the cloud releases all these water droplets, water vapor is going to be lost. Okay, so when it reaches here, water vapor is low. Okay, this cloud will just sink because it's because it's contracting with low temperature. It will just sink down. It's a dry cloud. All right, there's not any rainfall that's going to happen. So this whole area, um, in this side, okay, maybe from here onwards, it's going to be very dry. Okay, some people even consider from all the way from top all the way down, it starts to become dry. Okay, why? Because there's not enough rainfall. Okay, so the feature about the relief rainfall, or the key thing about the relief rainfall, is the fact that number one, it originates from the ocean. It gets pushed up by the mountainous areas. Okay, goes up all the way. Rainfall occurs only on the windward side. Okay, windward side, minimally on the leeward side, or nothing at all at the leeward side. Okay, so it goes down, it creates a dry area. Okay, so now what is the implication of this? I'm going to leave the mountain there because the implications will be better understood if the mountain is there. Okay, so usually what happens in this scenario, relief rain is not as extreme as convectional rain is. It's a lot more bearable in a sense, a lot more manageable. Okay, it doesn't cause much of flooding. It can cause, but not too much. Okay, so you on this side of the area, on the windward side of the area, you can have forests. Okay, you can have plantation. So it's much. Usually, this area is cooler. Okay, wetter. All right, conditions are less harsh. Okay, so people living in this area, they will experience a less harsh condition, a better condition in terms of living, etc. There will be trees, their plantations can work out because there's rainfall coming in. They can have agriculture, etc. So it's not too bad of a condition. Okay. However, on the other side, conditions will be a lot more harsh. Okay, you have very dry conditions. It feels very much like a desert, and there can be a desert. Okay, there can be a desert caused by this mountain range, if the mountain range is high enough. Okay, so conditions here are a lot harsher, drier. Conditions here are a lot better, less harsh. Okay, so if there is a question that asks you, okay, which part of the mountain would there be a better living standard, then it should be this side as compared to the leeward side. Okay, and finally, the one an important thing that I would like to say uh, is that now what I drew for you just now is a single mountain that looks like it doesn't cover much land. Okay, but in reality, mountain ranges are not like that. Okay, in reality, mountain ranges can be as like this and extends all the way down, and sometimes this whole area can also stretch out further. It really depends. Okay, so it can be way inland in terms of the width, especially, and in terms of height, it can go way higher up. All right, so you're talking about mountains that are so-called um, way much larger than what I drew out the diagram to be, and even the diagram in the notes. Okay, so why am I telling you this? So the reason why I'm telling you this is because um, the implication that I just said just now, the dry area and the wet area. Okay, because the mountain ranges are so large, this dry area and wet area can be even at national level. That means country to country changes, or even at regional level if the mountain ranges are really big enough. Okay, so please take note of that, and that explains why in your example I have brought about the 2 points of the Andes mountain range at Chile and Argentina. Okay, if you look at the map, all right, just a simple map. Okay, I can't looks something like this. South America. Okay, go and look at South America, and then Chile is on this side. Argentina is here, somewhere here. Sorry. Okay, Chile is somewhere here. Argentina is somewhere here. But the mountain range or South Andes mountain range goes all the way from here. I think somewhere along all the way up to the north of South America. Okay, South America, it doesn't stretch out to North America. Okay, so you got Argentina here and you got Chile here. Now, Chile experiences a much better climate. It looks like a tropical area, like semi-tropical area. But if you go on to Argentina, Argentina looks very dry. It looks sandy. It looks like a desert. Okay, grass and plants don't grow really well down there. The nature of the whole area looks like it's in one of those Middle Eastern desert areas. Okay, so it's a very stark difference caused by this mountain range and the continuous process of relief rain that occurs from uh, day to day. Okay, so take note of that. So you can cause changes at a even at the national level, okay, or regional level. Okay, so that's actually it for relief rain and convectional rain. Now, under the whole rain portion that we did, or not we did, I mean, there is a rain gauge portion. Okay, that's down there. It tells you we use rain gauge to measure waterfall. I mean, sorry, rainfall. Okay, and this rain gauge, like I said, all the tools are compiled them together, and I will talk about the tools separately when we deal with weather and climate field work. Okay, because all the tools got their own advantage, disadvantages, limitations, what you need to do, and all these things. So all these things will be specifically stated in a lesson that addresses the tools. Okay. Okay, since I have some time, I will just tap onto pressure a bit before we start to learn about wind and all this next lesson. Okay, so let me just present. You can copy down this part first. Okay, you can copy down this whole air pressure portion first. I will just explain to you uh, what air pressure entails and what we are going to talk about. Okay, so yeah, let's come back to the screen. Oh, where's my... Okay. Okay, all right. I need you to imagine. I know my drawing is not the perfect. Okay, never mind. I tell you what. I'll just use one cube instead, so it doesn't confuse you. Anyway, okay, so just imagine this is a cube of air parcel again. Once again, we are referring to air parcel. Now, what are we talking about when we deal with pressure? Is this force exerted by the air parcel on the Earth's surface? Okay, so in your PowerPoint slides, I mean in your notes, it says the force exerted on a unit area, okay, on the surface by the weight of the column of air. Okay, so we are looking at how pressure changes from location to location, and usually how it changes mainly has to do with number of air molecules inside. Okay, number of air molecules inside and how dense it is. Okay, how dense it is inside. All right, so if you naturally, if you squeeze the square, pressure will get higher. Okay, if you open up the square, pressure is going to get lower. Okay, at the same time, if you add more molecules in, pressure is going to get higher. Okay, if you reduce the number of molecules inside, pressure is going to get lower. So this conceptual understanding is crucial, but actually, honestly, when you start to explain the link between pressure and wind, uh, I wouldn't say it's too important for you to go and understand the whole theory behind this. But if I'm not wrong, you might learn this in physics as well, how pressure acts on different surfaces, etc. Okay, now in physics, I believe you might use a different measurement. Okay, here in job we use millibars. I think whether I think in physics is it pascals, or I'm not too sure, but yeah, anyway, in physics a different unit, so please take note of this in job. So if we ask you any questions, it will be in millibars. We won't put it in pascals or kilopascals or whatever of the other measurement. Okay, so just take note. Do keep an eye out for the unit that is being used in the question. You might get wrong if you go and use the kilopascal unit or etc. Okay, so we mentioned millibars. Yeah. Okay. Now, before I go on, or actually before I end the class, the last thing that I want to talk about is, okay, the last thing I want to talk about is temperatures influence on pressure. Okay, and next lesson, when I start next lesson, I will talk about altitudes influence on pressure. Why do I need to establish these two things? Okay, why do I feel that it's important to establish these two things? Because a lot of the things, when I explain later on for wind systems, these two things will play a crucial role in establishing where's the high pressure, where's the low pressure. Okay, so just now, as I mentioned, okay, if you have more particles, if you squeeze the air parcel and you have more particles inside, air pressure increases. If you open up the air parcel, not many air particles inside, pressure reduces. Okay, so if you keep the air particles constant, um, contract means high air pressure, expand means low air pressure. Okay, so naturally, if I have a high temperature, it will result in low pressure. Okay, if I have a low temperature, okay, it will result in high pressure. Okay, so that is the first thing that you want to know. All right, so once again, I repeat myself. If I contract same number of air particles, it becomes denser, pressure is higher. If I expand, same number of particles, it becomes less dense, pressure is lower. So high temperature generally relates to low pressure, low temperature generally relates to high pressure, okay? But when it comes to altitude, okay, I'm just going to establish the relationship first. Uh, you think about it, okay? Why this could be the answer? I mean, why this is the relationship? Along the weekend, and then sorry, not along the weekend. Along on Monday itself and Tuesday, and then I will explain to you all on Wednesday, which will be the next lesson. Okay, pressure, altitude's relationship with pressure is that as you go higher, okay, air pressure will decrease. Okay, now this key thing that I want to take note, all right, this whole relationship, it starts from sea level. Okay, it starts from sea level. Why am I saying this very importantly? Because if you go into the ocean and if you go down further and further, air pressure is going to increase again. Okay, so that's different. That's a whole different situation. We are not talking about atmosphere. So when we're dealing with weather, we are talking about atmosphere. So we are not dealing with the pressure under sea level. Okay, we're only dealing with air pressure. So which means that we're dealing with technically, I mean, we're only focusing on the pressure from sea level and above. Okay, so when I mean this relationship, as you go up higher, air pressure will decrease. It's a from sea level relationship. Okay, have a thought about it. All right. You don't need to answer this one on the Google Classroom. But yeah, think about it. What's the reason why this relationship exists? Okay, and yeah, that's it for today. All right. Uh, yeah, hope you understand what the rainfalls entail. No questions for today. Yeah, and have a good day. All right. Thank you, class.